Hi everyone, welcome back. What I'm going to do now is I'm going to do a cheat sheet for circles in contact. Right, it's an overview relevant to short and long questions. Now, I mightn't have every variation here, but I'm hoping that I'm going to be able to cover at least most of the examples that might come up in either a short question or a long question. Okay? So, typically appears as a short question, and then in a long question, a higher level, it tends to come in under your, it could be orthographic, it could be rotations, it could be your ellipse, parabola and circles question, and in ordinary level it could be your ellipse, parabola question, or your ellipse question, sorry, and your circles in contact question, which is the long one, question 6, okay? So, let's get to it. Here we have number 1, tangent to a circle from an external point. So we have a circle here A and we have an external point here B. What do? How do we draw the tangent? Do we just line B up with the edge of the circle? Well, we could, but that won't do us any good when it comes to getting a few marks in the exam. So what we do is we connect a point from the point B, the external point, to the center of the circle, like so. I then get my compass, okay, and that line now, AB, I'm going to bisect it to find halfway. So stretch your compass past where you think halfway is. For example here, swing an arc. Keep the same radius, go to point A, swing a second arc. Where the two arcs intersect, there are intersection points. We can join those, and now we have the halfway point located between A and B. We'll call that point O. Now, from point O, all you do here now is get your compass, put it on O, measure to either A or B, it doesn't matter. It's the same distance, okay? You see there, or you see here, okay? Same distance. And what you want to do is swing a semicircle, like that. You can do it in either direction. We want the tangent up on this side. Where that arc intersects the circle here, okay, we'll call that point X. We then join X back to point B, and that is our actual tangent line, okay? So X is the point of tangency, and that gives us our tangent line, okay? So tangent, T-A-N-G-E-N-T. Okay, tangent. Lovely. Next one. External tangent to two circles. Okay, so I have a circle here, radius 25. That's circle A. I have a circle B here, radius 15. What am I going to do? First thing I'm going to do is I am going to find the halfway point between the center point A and the center point B. So get your compass. Stretch it out past where you think halfway is. Swing an arc. I'll try and make these arcs as evident as possible. Go to keep the same distance. Swing a second arc. Naturally enough, where the two arcs intersect, we draw our bisector line, like so. Now, that's my point O. That's my center point. Between the two center points of the circles, I then take my compass, put it on point O, stretch it out to either A or B, it doesn't matter because we're halfway there. Swing a big arc like so. Okay? Now, what we want to do now in this case here is we want to do a little bit of maths. There's not a whole lot in it, so don't worry about it. We're going to do a small circle inside the big circle. Okay? And so in order to do that, what we do is we subtract the radius of the small circle from the big circle. So we take 15 from 25, okay? So I'll just write that down. So R25 minus R15 equals R10. Okay? So I'm going to measure R10 now on my, like so. And then I'm going to go to point A, the center point of the big circle, and I'm going to swing a circle with radius 10. Okay? So that's the R10. Now, what's that giving us? That's giving us an intersection point here. We'll call a point, we'll call this X. Okay? Now, what we do with X there is we draw from the center point A out through that point X. That point X is intersecting the semicircle we have here. Okay? And the radius 10, of course. So we draw that out. We get a point of contact up here. We'll call that Y. Okay? Now what I'm going to do is I'm going to use my sliding set squares technique, okay, to actually recreate that very same angled line from the center point of the circle B. So, draw that on. I'll just put in the symbol there to let everyone know that that line and that line are parallel. Okay? And of course, we'll call this point here, we'll call that Y1. Now, if I join Y and Y1, I get what we call the external tangent. Okay? I'll just put it in short. Lovely. External tangent done. Next one. Internal tangent. So I want a line running between the two circles. So, this time, we're going to follow the same process as the last one. We're going to go A to B, and we're going to find a halfway between both of those points. So I'm going to get my compass, to start here on B. I'm going to stretch it out to where I think halfway is, roughly, or past halfway, sorry. Keep the same distance on my compass, and do it from point A. Again, I'll make those as visible as possible to you. So you should see those arcs slightly. There are the intersection points. Okay. And I draw those. Okay. Apologies there, actually I forgot to draw in the line that connects A to B on that one, just so you can see it. And likewise here, A to B here. Now, just so we can properly locate the point O there. Now, there's point O halfway between. Next step there is to go from O to either A or B, it doesn't matter. They're both the same distance away. Okay, and we're going to draw a semicircle. Okay, like so. Now, that semicircle, how are we going to use it this time? Well, like the last time, we went to the big circle here and we drew a small circle inside it by subtracting the radiuses of the two existing circles. However, this time we're going to go to the big circle again, but we're going to add the two radiuses. So, we're going to have 30 plus 20. So, or, write it up here, or 30 plus or 20 equals or 50. And at or 50, we set it on our compass, like so. Go to point B, the big circle, and we're going to draw that. Okay? Okay. So you can see that big circle I've drawn there now. Okay. Now, where that big circle intersects the arc is off out here, isn't it? So there's the arc I drew there, connecting both points A and B, the initial one. And here is the big circle, or 50. Okay? So where they intersect, we'll call that point X. I'm going to join point X back to point B. Okay? Now, hazard a guess what happens here. Where that line intersects the circle, we'll call that point Y. And then we're going to use our sliding set squares again, and we're going to take the angle of that line, we're going to slide it over to the center point A, and we are going to redraw that line like so. Okay? So that's going to be parallel like so. And we will call this point Y1. Lovely. So I'm going to join Y and Y1. Okay, and that's going to be the internal tangent. INT for short and tan. Okay, that's how we find the internal tangent. Okay, pretty cool. Now, right, we're going to go to, well, I have 9, I have 7, 8, and 9 here, okay? I know we've done 1, 2, and 3, so I'm going to do these first before I get down to the bottom ones. Now, we have a scenario here, and it can come up in questions sometimes, where we have 3 points. We have A, B, and C, okay? So let me just connect A and B here, okay? And then we have point C right there. And we want to find an arc containing the 3 points A, B, and C. Well, what we have to do there, guys, is we have to join A, B, and C. Okay, so you can see the green lines I've put in there now connecting A to C and A to B. Okay, and what I'm going to do is I am going to bisect the line AC and find the center point. Okay, so I'm going to stretch out just past where I think halfway is between the 2 points. Keep the same distance on the compass. Apologies now if it goes a little bit up into the text. Now we're okay. And I get the 2 intersection points. And what I do is I draw a bisector line. Okay? Like so. I now go to A and C and I repeat or B and C and I repeat the process. So stretch it out to where you think halfway is, or past it, and again do the same thing. Bisect the line BC, 2 intersection points, and then what we're going to do is we are going to draw both of those like so. Now, there's my bisector. My bisector, where they intersect down here, that is the point that we are looking for, okay? And I am looking for my pen at the moment, okay? So, we will just mark the point, like so. Right there, we'll call that point O. Because point O now, if we get our compass and put it on point O, and stretch it out to A, B, or C, we should get an actual radius that is going to accommodate all 3 points. And you can see that. Now I'm not drawing in the full circle, but it passes through A, it passes through C, and it passes through point B. Okay? So that's how you find a circle to, or an arc containing the 3 points. You have to do a bit of bisection. Now, an arc to contain 2 points A and B. So, what I do here, I have A and B. I have no specific radius given to me. I want to find an arc that fits between them. Okay, what I'm going to do is I'm going to take the distance A and B on my compass, like so. Okay, and from point A, swing that arc. Okay, keep the same distance on the compass, go to point B, swing a second arc. Okay, that gives us our point O. Okay, then I take my compass, keep the same distance on it, and what I want to do is swing. Okay, and it's going to connect both points with an arc. Alright, and I just put in a little symbol there with radius. Okay, so that was quite simple. Take the distance between A and B in your compass. From A, swing an arc. From B, swing a second arc. Gives you point O. Put the compass on O. Turn it around and swing A to B. And that will get you an arc that connects the 2 points. Here now, we have 2 points A and B. And we want an arc, radius 50, between 2 points A and B. Okay, of course that radius could be anything, you know, but we'll just say it as 50 in this question. So there's A and B. We'll join them with a line there just so we're nice and clear on where they are. Okay, there's A, there's B. So I get my set square, my compass again, and now I am going to go to point A, swing an arc with a radius of 50. Apologies there about that now. And then go to B and swing an arc with a radius of 50. Okay, that gives me my point O. And I take my compass, put it on O. Alright, and what I'm going to do now is I'm going to swing a portion of the circle that contains both points. In other words, an arc. Look at that, okay? So we can see now there, and I'll just draw in the little line here to indicate the radius, just so you can look back and see R equals 50. there. Okay, and we can see how we found that. Nice and simple. Two arcs, swung from A and B, radius 50. Where they intersect, give you a point O and swing it around. Now, moving down to the bottom. Now, as you can see here, I have some information blanked out. That's because when I was doing out this example, it was running off the page, and I don't want that to happen. Okay, so I have just, in the crudest way, blocked out the previous information. Okay, just by colouring in over it. Okay. And what I'm going to do now is I'm going to demonstrate how to find this internal tangent circle with a radius equal to 80, okay? And how we locate the center point and so on. So what we do here is these two circles are going to be inside a larger circle with a radius of 80, okay? And they will be tangential inside. So we are going to take radius 15, we're going to take the radius 80, or 80, minus R15 equals R65, okay? And then we're going to have R80 minus R25, and that equals R55. Now, how do we use those radiuses? So, I'm going to take 65 on my protractor, or my compass, sorry, and I'll measure it out here. 65, go to point A, and the reason I'm swinging 65 from A is because that's the one for A, swing an arc. Then I'm going to change my compass to 55 millimeters, and I am going to set that on point B, and I'm going to swing a second arc. Okay, now where they cross over, they give me a point 0. Okay, I am now going to place 80 millimeters on my compass, so 0 all the way out to 80. And you might go, well, why 80? Well, 80 was just the one I used in the example, okay? And I put the compass on 0, and what I'm going to do is I am going to now draw the tangential circle like so, okay? So you can see how that tangential circle actually passes around the two circles but touching them at a single point. How do we locate the exact point? Well, we get our set square of point O, line it up with A, draw a line out through A. So on out through A from O, and extend it on to hit the circle. PC1. Point of contact 1. Okay? PC1. And then we're going to go from 0 out through point B, and we'll call that PC2. Now we have the 2 points of contact located. Okay? And that's as simple as that. Okay? So the key thing to remember here, internal tangent circle, we subtract the radius from the one that's indicated in the question. Okay, external tangent circle. This time we're going to find a circle that's going to fit between the two circles in this region here. Now we could do this region, we don't have the space though. So here we're going to have the circle. How do we find it? Well, we subtracted the radius last time, this time we're going to add. Okay, so R30 plus R15 equals R45, and then we have R30 plus R25 equals R55. Okay, so I'm going to take those two radiuses now. Okay, I'm going to swing the 45 from the center point A. I'm going to swing the 55 from the center point B. Where those two arcs cross over, we're going to locate point O, then put 30 on our compass and swing the desired circle. Okay, so 45 millimeters, like so. Okay, point A, swing an arc, go back, measure 55 now. The 55 goes on point B, like so. Swing another arc. That gives us point 0. Now, I go back to the question, I look at the initial radius, which was 30, and I set 30 on my compass now, and I put it on point O, okay, and I am now going to swing the circle with radius 30, like so. Okay, and you can see that circle, it's perfectly touching the two circles that I already have drawn. To find the points of contact, I must join the center points. Okay, like so, and I get point of contact 1 here, call that PC1, and then we join from O to B, okay, and we get the second point of contact, PC2. Job done. That is the external tangent circle located. Now, finally, down in the corner here, what we have is finding a circle between a line and an existing circle with a given radius of 20 millimeters. So I have a line, okay, I have a circle here that is radius 25 and it's located 40 millimeters up off that line, okay, which really doesn't matter in the context of any scenario. So what I want to do is I want to find a circle with a radius of 20 that's going to fit in here to touch the line, to touch the circle, single points of contact, okay. So what I'm going to do is, firstly, up off the line, I'm going to measure up 20 millimeters. Measure your 20 millimeters up, okay, with a little dot, and then what we're going to do is we're going to draw a horizontal line, like so. Now, I have that horizontal line, and just so you know, I will draw in a little dimension line there just to show that it's the 20. Okay, and that 20 is got from the radius 20 that's stated in the question. Okay, because somewhere on this line is going to be our center point. Sure, it has to be, because if it's radius 20, it means it's going to be 20 up off the line. So the center point has to be somewhere on it. But how do we locate that center point? Well, what we're going to do is we're going to add the radius 25 plus the radius 20. Okay, so if I add R 25 plus R 20, which is this here, that equals R 45. So I now get my compass, put the point of it on 0, measure out to 45 millimeters, go to point A and swing radius 45, like so. And again, I'll put in another little line here just to indicate the length of that radius. Okay, like so. R equals 45. And when you're looking back, you'll be able to link it in there as to where it came from. So, what we have got now is a point of contact. Okay? Or an intersection point. Sorry, not a point of contact. And we're going to call that point 0. That's the center point for our circle. And our circle has a radius of 20. So we can now draw that in and see if it works out for us. So, I'm going to get 20, like so. Put it on point 0. And I am now going to swing. I'm now going to swing a circle. Okay? And the circle touches this circle perfectly and the line perfectly. But again, we need to put in a small little construction detail for that actual point of contact in both directions. So the first one, we will do the O to A line. We'll join it with a line, the two center points. Where they cross over, that's our point of contact PC1. And then to find the point of contact between the circle and the line from point O, draw a line straight down at a right angle to the line. Okay? If that line was off at an angle, you'd be going at a right angle to it, whatever it was. And then you can locate the exact point of contact down there. We'll call it PC2. Okay? Now, so that is a cheat sheet guide to circles in contact. Now I know there's probably a lot to digest there, but it's something that when you are dealing with either a short or a long question in your revision, you will be able to jump back to this particular example, alright, this page, this video, and you'll be able to relate to you know, what you're being asked and what solution you need to draw your answer from. Okay? So thanks very much, and we will do more on circles in other questions as they appear. Okay, have a good one.